Welcome.
Welcome to today's webinar about Fronius PV charging solutions for forklift batteries. Today I want to show you how we combine PV production with your intralogistics. Then there is one big question: how can we organize our energy in a way that not only saves us money but also make us more independent and future-proof? Then one thing is certain: the energy prices are not going down. Today's agenda, we have a short introduction into the intralogistic. Then we will talk about PV Connect and load balancing following from their functionality. And in the end, we have an example for you. So let's start with the intralogistic. The intralogistics manage the internal material and good flows from receive to production and to shipping. So typical tasks from the intralogistics are internal transport, storage, and picking. In the intralogistics, a variation of different types of forklifts and pallet tracks are used. What many don't know, the intralogistic is a massive energy consumer. An 80-volt forklift needs around 8 to 10,000 kilowatt hours of energy per year. In comparison, and one family household in Austria needs around 4 to 5,000 kilowatts energy. So a big forklift needs as much energy as 2 family homes. And companies are not using only one forklift, they are using many more. Things can be rough in the intralogistic, but our batteries need one thing above all: careful handling. And for this, we developed the selectiva chargers with the RI charging process. The selectiva chargers can be used for lead acid, nickel cadmium gel, and lead crystal batteries. They support voltages from 12 to 80 volt, ampere currents from 30 to 375 amperes, and power classes from 1 to 30 kilowatt. We also offer 24 different charging characteristics, and one of them is the RI charging process. This is quite special because the RI charging process measures the internal resistance of the battery. This gave us an overview into the SOC, the state of charge, the age, and the overall condition of the battery. And with these parameters, we can create an individual charging characteristics. So no excess energy is put into the battery and no unnecessary heated up happens, because high temperatures are bad for the battery lifespan. And with the RI charging process, we can also reduce your energy cost to 30%. You can imagine our charger as a personal trainer, knowing exactly when a hard workout needs to be done and when regeneration is important. And the battery is like a top athlete, working every day, carrying heavy weights and working under pressure. But if the cool down or warm up is missing, performance drops. And that's exactly where our chargers come in. They deliver the right amount of energy at the right time. The results: a longer battery lifespan, more availability, and uh, less breakdowns during the day. Plus, you save money. Anyone working in the intralogistic knows a lot of things happened in the background, but they use a huge amount of energy. And that's exactly where our challenges begin. Let's start with a topic that affects almost every company with an intralogistic: rising energy prices. For the charging process of forklift and pallet tracks, a huge amount of energy is needed. In times of rising energy prices, the energy becomes a big cost factor, and not only expensive but also unpredictable. Between low prices on the weekend and high prices on workdays, there is a huge gap. Companies often don't know when the right cheapest charging time is, and even if they know, without an intelligent controlling, you can't take advantage of it. Even throughout already companies possess their own photovoltaic system, which produce cheap solar power during the day, and this is sold for a few cents. And in the evening, when the forklifts need to be charged, the power is uh, expensive power from the grid is used. Many more and more companies are under pressure from customers or political requirements to reduce emissions and increase sustainability. And this brings us to the most fundamental challenge, lack of transparency. Without monitoring or a smart interface to the energy supplier, future improvements are almost impossible. So enough of the problems. Let's talk about solutions we created. First, we have PV Connect and load balancing. PV Connect is a smart link between your charging infrastructure and your PV system. The system detects when PV power is available and starts the charging process. No manual interruptions, no complex coding. The control happens directly in the charger. We have two different modes available. First, PV maximum, where the maximum amount of your PV power is used for the charging process of your forklift. But load peaks can happen. And for this problem, we have PV optimal. Now we calculate the gap between the PV production and the used energy for the charging process. So even if an unexpected reduce of PV production happens, no load peaks appear. The benefits we are getting with PV Connect is that we can reduce energy cost and increase our self consumption of PV power up to 35%. The second key component is load balancing. This means intelligent load distribution. What happens if all chargers start at the same time? Overloaded circuits and expensive load currents by the grid operator. This can all be prevented with load balancing. The system detects how much energy is available from the grid or the PV system and starts the charge and distributes the energy dynamically. You can even set priorities. First charge the vehicles you need soon and then the reserve fleet. The results, you optimized your energy use, your availability and your operations all at once. So what kind of solutions we can offer with uh, load balancing and PV Connect? A well-organized charging infrastructure today is more than just plug and charge. It's a cost factor and the opportunity. PV Connect and load balancing brings the opportunity to reality. First, we can save energy costs. We achieve this with increasing our self-consumption of PV energy. Then we have the dynamic load management. With load balancing, we can avoid load peaks and reduce energy costs. Transparency and control. Many companies getting now the chance to understand their energy uses in the intralogistic, even with more locations. With the monitoring, with the Fronius portal, they can monitor consumption, PV usage, and availability of the charger. Energy independence. In times of rising or unpredictable energy prices, the own PV production becomes a competitive advantage. And this brings us to the integration into already existing systems. For example, if a company already possesses Fronius selective chargers and they are now thinking about buying a Fronius inverter, PV Connect and load balancing can be integrated afterwards easily. And sustainability that shows. Savings are not only appreciated internally but also shown externally by ESG ratings and sustainable reports. This builds trust by customer partners and employees. So let's talk about the functionality of the system. So what is required to implement the system? You need three essential components. First, we have the connected PV system, then the connected charging infrastructure, and the digital solutions. The connected PV system uh, contains of solar panels and an inverter. For example, a Fronius inverter, which tracks the data in real time. Then we have the connected charging infrastructure, which contains a selective charger from the newest generation, the fourth generation, the gateway and the gateway link to get access via LAN and WLAN for the charger. Then we have the digital solutions. PV Connect compares PV production with used energy for the intralogistic load balancing, avoids load peaks and reduce energy cost. Solar Web and Charge and Connect are for the visualization. The Fronius solution is a smart interaction of hardware components like the solar panels, the inverter or the charger, and software components like PV Connect and load balancing. Our goal is to use as much energy as possible for the charging process of our forklifts. So on the roof, solar panels generate energy. The energy is sent to the inverter. The inverter converts DC to AC energy and tracks the data in real time and send it to PV Connect. PV Connect now compares PV production with needed charging demand and distributes them dynamically. Optional, a tech ID system can be added to set priorities for vehicles. For example, forklift 10 needs to be fully charged until 6 a.m. in the morning, while PV Connect decides when to charge. Load balancing avoids load peaks during the charging process. PV Connect and Solar Web are used to access the data in real time. Now we can see the PV coverage of our charging infrastructure, how many chargers are active at the moment, and how many load peaks were avoided. Let's move to the visualization and monitoring. For this, we open Charge and Connect, select Charger and Load Profile. So what can be seen in this load profile? First, we have the PV coverage. In this example, it's 53.2%. Pretty good, I would say. Now in the energy diagram, you can see in yellow the produced PV energy and in blue the consumed energy for the charging process. And a two-day forecast can be created. This helps by planning the charging process of your forklifts. So let's move on to our examples. First, we have the industrial facility with a three-shift system. The company has a PV system with 150 kilowatt peaks. They are using 4 inverters, 3 Verto 33 kV and 1 Verto Plus 33 kV. 10 battery chargers, Selectiva 4.0, and 30 batteries. For each shift, 10 batteries. The battery have a voltage of 84 volts and 620 ampere hours. So the daily charging demand is around 800 kilowatt hours per day. This brings us to an yearly energy demand of around 200,000 kilowatts energy per year. With an energy price of around 15 cents, you get energy costs of around 30,000 euros. By using a PV system in combination with PV Connect, an average coverage of approximately 30 to 50% can be achieved. In this special example, this means savings of around 9 to 15,000 euros, and the actual potential is likely even higher if the system is integrated properly. So for the second example, I select a warehouse with one shift system because they cannot use a PV system. But for this problem, we have load balancing. 10 chargers are used again, and for this example, 10 batteries with 24 volts and 375 ampere hours. This is a battery for a pallet truck. The daily charging demand is around 80 kilowatt hours per day, and this gave us a yearly charging demand of around 20,000 kilowatt hours per year. We calculate this again with 15 cents per kilowatt hour, and we are getting around 3,000 euros of energy costs per year for the charging process of our pallet trucks. By using load balancing, energy costs can be reduced to 33% by avoiding load peaks. And now we have a custom example. For this, I select the Behrens Group, which which work in the timber industry in Germany. The company has a PV system with 199 kilowatt peak, and the yearly charging demand is around 300 megawatt hours per year. So they use very much forklifts and chargers. With the integration of PV Connect and load balancing, we can get a PV coverage of around 36% uh, uh, around the whole year. This equals to 107.5 megawatt hours of energy per year. This is quite a big number. The Behrens Group already possess Fronius chargers and Fronius inverters. So in the amortization calculation, only the additional costs are added, like the ABOs for PV Connect, load balancing, solar web and charge and connect, and the needed gateways and gateway links. The result can be shown. We get an amortization period of just 1.3 years. After that time, the system generates money for us. So you see, thank you for your attention, and if you have questions, you can now ask the questions in the chat.